Hey everybody, welcome back to another episode of Rethink Connectivity. My name's Jeremy, and today we're going to be kicking off a brand new series all about NATS JetStream. Today we're going to be covering the fundamentals and some of the very basics of JetStream, but don't worry, if you're a JetStream pro, there's going to be some pieces in here, specifically with the new JetStream API that you're not going to want to miss out on. And if you do know JetStream like the back of your hand, go ahead and share this video with a coworker or a colleague. I'm sure they'd really appreciate it. So let's dive straight in. One of the questions I get when I talk about NATS to people is they've heard of JetStream and they're like, what the heck is JetStream? And today we're going to cover all of it, at least a high level overview of how it works. And we're going to dive in and write some code as well. So what is JetStream? Well, I like to start talking about what JetStream is by talking first about what core NATS is and then illustrating what JetStream is. So core NATS, as you probably already know, is a publish-subscribe model, meaning you have clients on this end. One of them's publishing and the other one is subscribing to a particular topic or a subject in NATS case. And the NATS cluster is there to broker the communication between those two things. And when I say publish and subscribe, I don't necessarily mean just pub and sub. You know, we can do request reply, fan in, fan out, all these different kinds of patterns here. But a lot of core NATS is very much the same, where a NATS cluster is really brokering communication between two live clients, right? Now, the problem for a lot of patterns kind of breaks down when one of these goes offline. Let's say this subscriber goes offline, maybe it crashed or maybe it just gets shut down for an upgrade or something like that. The publisher is going to publish the message and the NATS cluster is going to be like, well, there's no subscribers, so I'm just going to drop the message. Or it's going to deliver it to subscribers that are online, but it's not going to keep that message around for that subscriber that went offline. And this is known as temporal coupling, meaning I'm going to be sending messages around and whoever's online is going to get them. And if they go offline, they're not going to get them, meaning that if logic is related to these two clients, they are kind of temporally coupled together, meaning they are coupled in the sense that they both need to be online for them to work. And the core NATS can work for a lot of use cases. Like, I think it's fantastic for RPCs and for microservices and things like that. But when we're talking about things like stream processing, or we have a big set of data that we need to kind of distribute around and have things process, one at a time or multiple at a time, that's when we start getting into this idea of temporal decoupling, meaning I can publish a message and it gets stored somewhere. And then whoever wants to kind of get that message later can get it whenever they want. And this is where NATS JetStream comes in. So I'm going to go over and pull up this JetStream diagram. Now, don't be overwhelmed just yet. I promise we're going to cover all of this, and it's actually fairly simple. And so if we take that same model of like kind of publisher and subscriber, and we kind of flip it on its head a little bit and say it's publisher and consumer, because consumers don't actually just subscribe to data, they actually consume a piece of data, and we'll get to that in a sec. You can see that there's a lot more going on here. And so at its core, NATS JetStream, it's bundled in with the NATS server, but it's actually a subsystem of NATS, meaning it's something that you could turn on optionally or you could turn off optionally. And it really still is built on top of core NATS. It's not like it uses a different protocol or anything like that. It's all still NATS under the hood. And what happens is you have a publisher that instead of making a publish to the NATS server, it's actually making a request to that same subject, hello world. And it's going to be getting a response back from the server, which we call a pub ACK, or a publish acknowledgement. And this is just telling the publisher that the NATS server has saved that message somewhere. Now, what does somewhere mean? Well, more specifically, inside of the NATS cluster, we have multiple peers that make up that cluster, or multiple nodes. And these nodes communicate with each other to be able to kind of shuffle data and messages around. This is the case for core NATS as well as the case for JetStream. With JetStream, the clustering mechanic gets a bit more complex in the sense that I can say I want a stream of data to ingest every kind of subject that kind of comes along under this particular pattern. So I can say hello.star for anything that's, hello.world or hello.bob or hello.jeremy. And it's going to go and save that into a stream. And that stream is going to order each of these globally, which is actually a very important topic that we'll cover more. Global ordering is super important. But it's going to save these into a stream. And optionally, it's going to actually replicate those streams amongst the nodes inside of the NATS cluster. And so you can tell NATS to say, hey, I want the stream, but I only want it to be one replica, meaning it's just going to exist on one node. What happens when that one node goes down? Well, then you're kind of out of luck. You can't write to it, you can't read to it, or anything like that. JetStream is built on top of an implementation of the Raft protocol, which is a consensus protocol that allows us to replicate things and make sure that there's consistency, right? And so I can then tell JetStream to say, hey, I have this stream and I want to actually replicate it 3 times. And NATS is going to kind of figure out, and JetStream is going to figure out which nodes, are available to be able to kind of, store these things and pick, 3 nodes to store them on. And it's going to make sure that the data is replicated through all of those nodes. So if one node goes down, you can still read and write to that stream because you still have 2 that are up. If a second node goes down, you can actually still read from that stream because the data is still there and there's still 1 node that's up. If all 3 go out, well, that's why we have disaster recovery and things like that, right? But the main kind of point is that all of this data can be replicated in any sort of configuration, and it's very, very flexible. And so if you can kind of imagine kind of a sequence of messages that are coming through here, we talked about how those things get published and how they get stored, but how about how they get consumed? Well, this is the other little piece of the puzzle is we have a consumer API for JetStream, where we might have a client on the other end here that's kind of acting as a consumer. And what they do, and again, a lot of this is all covered under the hood inside the client SDKs, and we'll kind of show you and walk through what it looks like and how easy it is to do these things. This seems kind of complex over here, but it's a good high level overview, and then we'll work with the code soon enough here. But the client consumer makes a request, and this is just a simplified version, but it makes a request to the JetStream API. Now, the cool thing about this is you're probably looking, what's this $JS? Well, do you know what? JetStream is actually built on top of core NATS request reply, meaning that you could technically just use JetStream by making a bunch of requests and replies. All of your subjects will be long and it'll be kind of fiddly to figure out, but all of these things are open for you to use, which is really, really cool. And so all the client implementations are essentially built on top of this, where a consumer can say, hey, give me the next message or the next batch of messages or whatever. I'm ready for some new messages. And the cool thing, and the best way I like to describe consumers here, is consumers are like windows into a stream. And so you might have a consumer that says, hey, I'm interested in all of the data from this stream, or actually maybe just a subset of the data from this stream. Let's assume for a second that this consumer is interested in Hello World and Hello Bob. And so they might, filter on those as an example. And so instead of delivering the whole stream of data like you would normally have to do with something like Kafka or other kind of stream processing tools, NATS can actually filter on a consumer level, meaning this consumer says, I'm only interested in Hello World and Hello Bob. And so the NAT server is going to easily figure out whenever the next message needs to come for a consumer that it can deliver these messages 1, 2, 6, 7, and 8 because they align with those particular subject filters. Now, one other thing to call out here, and it's a really important kind of underlying bit of NATS JetStream, is that streams are indexed on a subject level. And this is really, really cool because it means instead of having to whip through an entire stream to get at a particular message, if you know the subject, you can actually filter down, quite well to get at that particular message. And this is actually what under the hood drives a lot of our KV and object store implementations, is this idea of indexing on a per subject basis. So streams are replicated across nodes. Consumers are also stored on the server and replicated across nodes, so your consumers can stay stateless, or your clients, that is, can stay stateless. And so they make a request, they get messages, and then they acknowledge that they've received those messages. Like I said, this isn't just a subscriber, this is a consumer that is consuming messages. So they need to be able to tell the server, hey, I've processed it, I've processed it, I've processed it, or even in some cases, I've not processed it, or I'm in a really bad state. Don't send more messages to me right now. We'll talk about consumers and go a lot deeper into how to configure them and how to have different kind of response patterns for consumers. But just know that a consumer is about consuming these messages, so we need to have an acknowledgement that a message was received and or processed. And that's it. That's kind of a high-level overview of how NATS JetStream works from a publisher and consumer model. There's a lot under the hood in terms of different kind of configuration patterns that you could do for different types of solutions that you might want to build. But let's go ahead and jump straight into some code, and we'll write a publisher, we'll write a consumer, and we'll walk through all this together. Okay, so I'm at my terminal, and if you know how I like to mostly do demos, we're going to be writing this thing from scratch. Okay, so it's not going to take a very long time. One of the things I wanted to show is like if I could do this in 5 or 10 minutes, you probably can too. And so I'm going to write this in Go because Go is kind of our golden SDK for NATS. But I assure you, all of these functions kind of exist inside of all the other client libraries. So you can follow along really easily here, and you can also kind of jump into your language of choice and do very much the same things. So I'm going to fire up a new main.go file for my publisher. I say package main and func main for my entry point. And then I'm going to go ahead and make a connection to a NATS server. And instead of connecting to a NATS server that I'm running locally, I'm actually going to use a service. I'm going to use Synadia Cloud. And you could follow along and do the same exact thing here. Let me pull it up. Synadia Cloud's really cool because you could sign up. It's free, and it's just kind of a global NATS network that you can use for free for a lot of kind of playing around and developer stuff. And so I can view my connections here. I can also look at my streams. And what I wanted to show you is I don't have any streams yet. So I can go ahead and I could create a stream directly here in Synadia Cloud. But what I want to show you is I want to show you the new JetStream SDK and what it looks like to create a stream. Now I've already created a user here. Called a user, and I've downloaded the credentials. And that's an important bit that we're going to get into right now is you want to make sure that you have your credentials downloaded and that you can access them from the program that you're writing. Okay, let's jump back over, and I'm going to say nc and error to get my NATS connection, and I'm going to say nats.connect. And I'm going to connect to Synadia Cloud, which the connection URL is connect.ngs.global. I can type it. There we go. And then I'm going to add my my credentials with nats.user credentials. And these are going to be user.creds in the directory above me. And then lastly, I want to give this connection a name so I could see it in the connection graph with its name. So I'm going to say nats.name. It's just going to give a name to my connection. So for monitoring and stuff like that, it's really easy to kind of pull it out. I'm going to just call this orders publisher, and we're just gonna pretend like we have some sort of order system in place. Okay, so I'm going to say log.fatal to handle this error. We're just going to handle errors very naively here in Go. But now let's move on. We should now have connected to NATS, and now we have to actually work with the new JetStream API. So for those of you who don't know, we rewrote a lot of the JetStream client APIs earlier this year. They're so much cleaner. So if you haven't gotten a chance to check out the new JetStream APIs, now's your chance. We're going to let's go ahead and close that out when the main function has finished running. And then we're going to create a JetStream context. And so the way that we do that is we're going to call the new JetStream API. What we would do before is called nc.jetstream. We're going to get rid of that, and we're going to actually pull in the new JetStream package. It's included with the Go SDK, and we're just going to call new. And this is going to give us a bunch of new functionality around JetStream, creating streams, updating streams, being able to publish and subscribe and things like that. So, all right, so we have our JetStream context, and now we're going to go ahead and, we're going to create a stream. Thanks, Copilot. All right, so we're going to add our stream with our stream config, and it's actually not called add stream anymore. We actually have brand new methods for this. It's going to be create or update stream. And the reason we want to do create or update stream here is we're going to run this program multiple times. And so we want to be able to kind of run through it and make sure if we make any updates to the config of the stream that it kind of matches the program that's running. So we're going to call creator update stream. The other thing that you'll notice, if you are a gopher like me, is that a lot of these functions now support the context package. So things like, deadlines and cancellations and all that kind of works inside of the new JetStream APIs, which has been a hugely requested feature, and now we have it in here. So I'm going to go ahead and just define my own kind of context variable with context.background over here, and then we'll go ahead and we'll pass that context over here. So we have the context pass, and then the second arg is going to be our stream config. So I could just type JetStream stream config. And I'll show you all the different options that are inside of this stream config. We're not going to use nearly all of them, but you can see that there's so many different things that you can configure inside of a stream, and we will dive deep into what all of these kind of features mean and how you can use them in different patterns. But for now, we're going to be doing just a simple kind of, publish and consume model. So we don't really need a ton of these. I'm going to keep these first three, and then I'm also going to add max bytes because I am using Synadia Cloud, and it does require that I set max bytes on all of my streams to make sure that I don't DOS Synadia Cloud, right? Okay, so let's give this thing a name. I'm going to just call this orders, and we could just say messages for orders. And then we're going to pass in subjects. So the subjects that we're going to pass in is orders.star. Actually, let's make this orders.greater than. So anything that starts with orders dot and has anything after it, it's going to end up in this stream. And so anything that consumes from this stream is going to be getting all of those messages, which is really, really awesome. So you can kind of see how this, the streams complement core NATS in a way where it kind of slurps up all of the messages that come in under a particular subject namespace. Okay, cool. So let's handle this error. Oops. We'll handle this error here. And our stream is now created. We don't have to do anything with our stream, which is why we have an underscore here. Instead, we're going to just start publishing. So we're going to just have a brute force way of publishing, which is that we're going to just have a for loop here, and we'll say I equals 0, we'll say I++, and then we'll start publishing. Now, instead of publishing to orders new, let's go ahead and say sprintf. We're going to go ahead and print orders dot, and we'll say %d for digit, and we'll include the I there. And so, so that way we can kind of know when we're scanning through things which kind of order that we're processing. And yeah, we could just say hello world is the payload here. We don't really need to do anything else fancy here. It says not enough arguments to call in JS publish. That's once again because the API has changed a little bit. We need to pass a context in there so we can handle deadlines and things like that if we need to. And there we go. We've now published that message with JetStream. And if there's an error, it's saying log fatal. Let's actually change that to a log.print because I don't think if there's an issue that we want to just close the program, but we will just continue the loop in that case. And then, yeah, we could just say we've published the message. And that's pretty much it. That's all we got for that publisher. I know it was, a bit of lines of code, but that's mainly because Go is pretty verbose with its error handling. But you could see, pretty simple. We created a stream. We've published, a bunch of messages. Let's actually see how this runs. I'm going to say go run main.go. And we've connected to the server, and now we're publishing messages. Let's go over to Synadia Cloud and see what that stream looks like. I'm going to go over to streams. And you can see we have our order stream, and that has 109 messages in it, 160 now. So we're publishing pretty quickly. It has one replica. But I could easily change this to 3 if I wanted to. But yeah, let's actually go ahead. I'm going to look at consumers. Yeah, we don't have any consumers yet. So let's go ahead and create another program that's going to be kind of the consumer in this model and going to be kind of slurping up all of this data. So I'm going to go over here to consumer, and we're just going to, again, create another main.go file. I'm going to start from scratch. And one of the things we'll do is we'll copy some of this code from the publisher, all this connection code and stuff like that, the context, And let's go ahead and organize our imports so we're not being yelled at. Okay, cool. So we now have a consumer. Let's rename this to orders consumer. And we have our JetStream context, and now we need to start consuming from this stream. So the way that we do that is we can actually just say stream and error is js.stream, and we get to look up the orders stream here. Let's go ahead and handle this error if for some reason we don't get a stream back. And then we can start consuming from this stream by creating or updating a consumer. Now, again, like I described in the diagram, consumers live on the server side, and clients participate in consuming from a particular consumer. And it doesn't have to be a one-to-one mapping. In fact, I could have a lot of clients consuming from one consumer, and they're naturally load balanced between them, which is slightly different than what you would kind of experience in Kafka, where you might have to do some partitioning, or you might have to create a consumer group, and then you have your consumers, and it gets a bit complex there. Here, it's actually really, really simple. And so I just noticed I have an error here because I need to pass my context. I keep forgetting. Okay, there we go. So we have our stream now, and I can now just say stream.create or update consumer, and I'm going to pass in my context, and then I'm going to pass in my JetStream consumer config. And very similar to the stream config, the consumer config is going to have a ton of options. We'll go over a lot of these in a future video, but the ones that we just need to kind of pay attention to are really these first two, name and durable. So I'm going to say orders processor. That's what I'm going to call this consumer, and I'm going to say the same thing for durable. Now, the reason we want to do durable is by default, consumers inside of NATS, since they live on the server, they are ephemeral by default, meaning we're going to fire one up and we're going to use one as long as the client's alive, and then if the client dies, it's going to kind of have some sort of timeout and then eventually clean up that consumer. But we want to keep this around for the long haul, so we're going to give this a durable name. And then we're going to assign this to a variable. We'll just say consumer and error, and we'll handle this error very similarly. And then we can start consuming from this particular consumer. And this is my favorite part, is because the old JetStream APIs were kind of a little rough to deal with when it came to consuming things, and there were just so many different options. We had push consumers and pull consumers, ephemeral and durable, and blah, 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 blah. Now it's just so much more simple to consume from, and I think the team did a great job. So all we need to do is we need to call consumer.consume, and that's going to allow us to pass in a callback, and I'm going to say this is a message, which is a JetStream.message. And this is an interface. So great. So we have a callback now to consume that message. And for every message that we've received, we are going to have this thing get a callback. So we could just say, whoops, I spelled that wrong, MSG for message. We can say, here, we're going to print out the data, or we're going to print out the subject. And so you can get all of the things related to a message directly from this interface, the headers, metadata, which is new in 2.10, all kinds of really fun stuff. And like I mentioned, consumers don't just subscribe to data, they actually consume them. So we need to make sure that we do an acknowledgement that we've received that message. And that's pretty much it when it comes to consuming. The other thing that we'll probably want to do is just, a little bit of hygiene from a code perspective, and that's we want to make sure that we handle kind of graceful shutdown. So this consumer consume can return an error, and it does return a consume context, which we will want to stop when we gracefully shut down. So let's make sure we handle this error. And then we'll also make sure we do some sort of graceful shutdown, which the way we want to do that in Go is we want to kind of listen for a signal. And, if that signal is heard, we want to make sure that we kind of clean things up. So we'll make a channel of a OS signal. We'll use the signals package for this. There we go. And we'll say signal.notify on interrupt, and we'll listen for quit. And that's when we'll actually do a stop. Now, the other thing we could do is we should be able to just say, put this in a defer statement like that. and that will kind of close everything out. So there we go. Our code is complete. We've created a consumer. Let's hope that it works. Fingers crossed. It looks like everything's pretty good here. Let's go ahead and run it. So I'm going to say go run main.go. And we've connected, and you could see that it's processing all of these messages, and now it's slowed down a bit. That's because it was catching itself up. And so now that we have kind of consumer running, I want to kind of showcase, a little bit of what this looks like. Is it's processing messages, and now it's kind of in real time. You can see it's caught up the 4300s with the publisher. It catches up pretty quickly. But I'm going to go ahead and close this out. And if I run this again, it's going to be all caught up with the publisher. And so it's going to pick up right where it left off, which is really, really neat. The other cool thing that I mentioned previously is that consumers can share a lot of different clients. So I can go ahead and run another one of these, and you'll notice that they'll kind of slow down, and that's because now the consumers are kind of outpacing the publisher, and they're now load balancing essentially all these messages that are coming from the publisher, which is really, really neat. And if I go over to Synapse Cloud, I can actually go over to my connections here, and I can see that I have 4 order consumers and 1 orders publisher. And this is, again, the really neat part about Synapse Cloud is I can kind of visualize all of these things here. I'll go back to my streams, back to orders and consumers, and you can see that I have my order processor, and it looks like it has 0 pending, which means it's up to date and it's processing everything. But yeah, that's a high level overview of what it looks like to build a publisher and a consumer in Go with the new JetStream APIs. I'd love for you to give this a shot. And stay tuned for future episodes. We're going to be covering a lot more when it comes to JetStream. We're going to dive deep into streams and configuration, consumers. We're going to talk about KVs and object stores, and we're going to even talk about how to operationalize a lot of your JetStream clusters. All right, until next time, thanks for watching. I'll see you in the next one.